What's up, everyone? This video is continuation of my efforts to make some of the HDAs that I'm working with in Houdini all the time, to make them available as its own standalone tool, and also upload them on Orbolt so that they are actually available for all the versions of the Houdini. And in this video, I want to talk about the transform to origin HDA node. So the idea behind this node is that we can take primitives from any geometry and we can align basically the surface. We can take the normal of these primitives and align them across the x or z axis. And this gives us our normalized working space that then we can go ahead and work on with some procedural logic, in this case for something like roof tiles. So if you have to go ahead and disable the roof tile logic, and I do not transform these primitives back to its original place. I just go ahead and put it on a for each loop. You can see that all the geometry has been aligned along the either x or z axis, and the node has option to align either to the x or z axis, and there's also option to align uh, the match size of parameters has been promoted to this HDA so that we can go ahead and move this geometry more if you want your adjustments to be also made once it has been aligned already. So that's not the that's kind of like convenient parameters also added. We basically have to point to the normal that you want to align from, and in this case I have set up my primitive. I have put down a normal node, which basically is we have added the primitive normals as its own attribute, and the node is going to automatically pick up any vector primitive attributes on this attribute parameter. In this case, I can only select normal, and then you have to give a primitive to sample from. In this case, it's always going to be 0 because in the for each loop, the primitive numbers reset to the 0. So this can be also done outside the for each loop. So let's say I want to align the geometry across something like this primitive. Only thing that I have to do is go ahead and take a look at the primitive number. So this is a primitive 6. Say that, okay, I want to align it along the primitive 6. And you can see we have aligned. You can see this primitive is now flat across across the x-axis or a z-axis. It is being flat and all the geometry is being rotated along it. So that's how you can select the attribute from, or you can use a custom attribute, and the custom attribute is going to basically say, okay, so if you want to across the y-axis, you can see now the geometry is being so basically the y is being taken and aligned across the z or x-axis. So but in this case, I'm using the normal attribute to align it using my procedural logic for the roof tiles. In this case, it needs to be Z. And then just go ahead and for each loop. And it is important to, in this case, I'm using a little bit of offset because of the roof tile that I create to make them connect a little bit better. And it is important to use the transform by attribute node, which is the default Houdini node. We just basically have to give it an attribute that you want to move your geometry back from. And the transform to origin node is going to create this xform to origin detail attribute. And the only thing that you have to do is go ahead and point it. It's going to be automatically picked up by transform by attribute node. You can just go ahead and select it, and that's basically it. You can go ahead and it's going to automatically align your geometry back to its original position with all of your edits done. So that's the basics of the node, and I mean I have been using it a bunch of times for the building walls, and roofs. When you want to create something like some wall geometry, I mean it's really helpful to have something like this. So one thing that you have to one last thing that I want to talk about is this y-aligned adjustment. So the idea is that when you have geometry and some of the vectors, and if any of the vectors points exactly towards y or negative y, because of the mathematics that goes behind the scene in the transform to origin node, geometry can be basically aligned vertically instead of horizontally. If you go ahead and take a look at the, let's go ahead and let's disable the roof tiles, and let's disable also the let's do the transform, but let's go ahead and do the single line, single adjustments. You can see in this case I'm using the geometry that is exactly y aligned, which is basically positively y aligned. So this is going to be a problem if you do not use these y aligned adjustment parameters. So let me go ahead and disable them. You can see that by default it's going to basically point towards up vector. And for our roof, this is not the ideal way to work with, because right now you can see our roof is being aligned kind of like horizontally because of our procedural logic for the roof. It would be great if we would move these tiles the other way around, so that this geometry would be basically rotated 90 degrees and be kind of like horizontally aligned instead of vertically. So this is where the rotate positive y vectors and negative y vectors come in handy. If you go ahead and select this one and say that you want to rotate them, you can basically select either you rotate them 90 degrees or negatively 90 degrees. You can see in this case, since I am center aligning them, it doesn't look that I'm doing anything, but you can see if you look at the point numbers, you can see we actually move them by 90 degrees. And this allows for us to use our logic. You can see in this case, our roof is now being aligned, our roof is now being created because of the alignment of the geometry. And it's basically the same thing for the rotate y, negative y vectors, which points towards negative y. And in this case, I don't even think that I have, I don't even, in this case, I actually deleted them. So that's thing to look out for. And let me go ahead and turn off the single path. So if you take a look at this, something like this, and if you change the rotation 90 degrees or negative 90 degrees, you can see that you can change also the tile direction, because you basically flip the rotation, and whatever the best case for you is you can go ahead and rotate them also. In this case, it looks like this should be the way to go. And that's it for this video. I hope you found this HDA useful, and see you next time.